What is stack trace analysis and why is it important? Have you ever run into an error while programming and wondered how to find out what went wrong? Today, we are going to talk about stack trace analysis and why it matters in debugging. Stack trace analysis is all about examining a stack trace. This is a detailed report that shows the sequence of function or method calls a program was executing when an error occurred. The stack trace lists these calls in reverse order, starting from the most recent function where the error happened and tracing back through the chain of calls that led to that point. Each entry typically includes the function name, the file name, and the line number in the source code. This gives you precise context for the error. To understand stack trace analysis, you need to know what a stack trace represents. When a program runs, it keeps track of active function calls in a structure called the call stack. Each time a function is called, an activation record is pushed onto this stack. This record stores information like arguments and local variables. If an error occurs, the stack trace captures the current state of this call stack, showing the path the program took through its code just before failing. Now, why is stack trace analysis important? It allows developers to pinpoint the exact location and cause of bugs quickly. By following the sequence of function calls, developers can identify which part of the code triggered the error and understand how the program reached that state. This is especially useful when debugging complex applications, where the root cause might be several layers deep in the call hierarchy. Practically, stack trace analysis helps you locate the exact line of code where an error occurred. This saves time compared to guessing or doing extensive manual code review. It also helps you understand the flow of program execution leading to the error. This can reveal logical mistakes or unexpected conditions. Additionally, you can identify patterns of failure by examining recurring stack traces in application logs. This can indicate systemic issues that need to be addressed. If you are debugging parallel or multi-threaded applications, analyzing stack traces from multiple processes or threads can help you find synchronization or concurrency problems. For software developers focused on mastering debugging and fixing bugs, learning to read and interpret stack traces is fundamental. It allows for faster diagnosis and resolution of issues, improving software reliability and reducing downtime. Tools exist that aggregate and simplify stack trace analysis, especially for large-scale or parallel applications. However, the core skill remains the ability to interpret the call sequence and relate it to the source code. In short, stack trace analysis is a key debugging technique that reveals the path a program took before an error. It helps developers find and fix bugs efficiently by providing clear, actionable information about the error's origin within the code.